Understanding the problem. It is foolish to answer a question that you do not understand. It is sad to work for an end that you do not desire. Such foolish and sad things often happen in and out of the school, but the teacher should try to prevent them from happening in his class. The student should understand the problem, but he should not only understand it, he should also desire its solution. Wow. If the student is lacking in the understanding or in the interest, it is not always his fault. The problem should be well chosen, not too difficult and not too easy. Natural and interesting and sometimes should be allowed for natural and interesting presentation. First of all, the verbal statement of the problem must be understood. The teacher can check this, and up to the certain extent, he asks the student to repeat the statement, and the student should be able to state the problem fluently. The student should also be able to point out the principal part of the problem, the unknown, the data, the condition. Sure. Hence, the teacher can seldom afford to miss the questions. What is the unknown? What are the data? What is the conditions? The student should consider the principal part of the problem attentively, repeatedly, and from the various sides. If there is a figure connected with the problem, he should draw a figure and point on it the unknown, the data. If it is necessary to give names to these objects, he should introduce suitable notation. Devoting some attention to the appropriate choice of the sign. He is obliged to consider the object for which the signs have to be chosen. There is another question which may be useful in this preparatory stage, provided that we do not expect a definitive answer, but just a provisional answer, a guess. Is it possible to satisfy the condition? In the exposition of the part second 2, understanding the problem is subdivided into 2 stages: getting acquainted and working for better understanding. Again, understanding the problem is subdivided into 2 stages: getting acquainted and working for better understanding. Example. Let us illustrate some of the points explained in the foregoing section. We take the following simple problem. Find the diagonal of the rectangular parallel piped of which the length, the width, and the height are known. So again, find the diagonal of the rectangular parallel piped of which the length, the width, and the height are known. In order to discuss this problem profitably, the students must be familiar with the theorem of Pythagoras and with some of its application in the plane geometry. But they may have very little systematic knowledge in the solid geometry. The teacher may rely here upon the student's unsophisticated familiarity with the spatial relations. The teacher can make the problem interesting by making it concrete. The classroom is a rectangular parallel piped whose dimensions could be measured and can be estimated. The student have to measure indirectly the diagonal of the classroom. It's very concrete, yeah? The teacher points out the length, the width, and the height of the classroom, indicates the diagonal with a gesture and enlivens his figure drawn on the blackboard by referring repeatedly to the classroom. See. the dialogue between the teacher and the students may start as follows. What is the unknown? The length of the diagonal of the parallel piped. What are the data? The length, the width, and the height of the parallel piped. Introduce suitable notation. Which letter should be which letter should denote the unknown? X. Which letter would you choose for the length, the width, and the height? A, B, C. What is the condition linking A, B, C, and X? X is the diagonal of the parallel piped of which A, B, and C are the length, the width, and the height. Is it a reasonable problem? I mean, is the condition sufficient to determine the unknown? Yes, it is. If we know ABC, we know the parallel piped. If the parallel piped is determined, the diagonal is determined. Ha 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 ha. So good, so good.